What if I told you the first people to predict the future didn't read tea leaves? They read the stars. From clay tablets in Babylon to stone-carved codices in Mesoamerica, ancient astronomers, or, as the title says, astronomists, turned the night sky into the earliest data science lab. And here's the twist. Centuries before Copernicus, one Greek guy already said the sun was at the centre. We'll get to him. But first, let's rewind to the world's very first sky trackers. By the end, you'll see how ideas passed like a torch across civilizations, Babylon to Greece to India to the Islamic Golden Age, eventually lighting the path for modern astronomy. And one forgotten model you'll hear today looks suspiciously like what Copernicus later used. Let's start where astronomy becomes organised, numerical and obsessively precise. Ancient Babylon. 1. The first sky trackers, Babylonians circa 1800 to 500 BCE. They weren't philosophers. They were obsessive record keepers. On clay tablets, Babylonian scholars tracked planetary motions, eclipses and lunar cycles with almost bureaucratic discipline. They compiled omen series like Enuma Anu Enlil and created arithmetical schemes to predict planetary positions, a kind of proto-algorithmic astronomy. Their Saros cycle-based eclipse predictions laid the data bedrock future astronomers stood on. But how did the Greeks transform those raw numbers into cosmic architecture? Stick around, one of them will argue that the Earth moves. 2. Nile timers, Egyptian astronomers, circa 3000 to 300 BCE. Egyptians used the sky practically. Sirius's heliacal rising signalled the Nile flood. Their 365-day civil calendar was a direct astronomical tool, temples aligned with solstices and cardinal directions, embedding cosmology in architecture. They didn't pursue theory like the Greeks, but they measured time, ritual, and agriculture through stars, and built monuments that still point to the heavens. But a culture to the east built an astronomical bureaucracy that tracked comets, novae, and eclipses for millennia. We'll get there after the Greeks shake the cosmos. 3. Thales and Anaximander, the first Greek sky thinkers, 6th century BCE. Thales allegedly predicted an eclipse, possibly using Babylonian cycles, bringing astronomy from omen to geometry. Anaximander imagined the Earth floating in space, unsupported. A radical step away from myth. They sowed the crucial idea: nature is knowable through reason, not only through gods. But the next Greek generation will push numbers and purity, literally perfect circles in the sky. Why circles? Because the heavens must be perfect, right? 4. Pythagoras and Plato, math, harmony, and perfect circles, 5th-4th century BCE. Pythagoras linked cosmic order to mathematical harmony. Think music of the spheres. Plato, in the Timaeus, demanded astronomers save the phenomena, using uniform circular motion, set in a philosophical constraint that would dominate astronomy for centuries. The sky wasn't just observed, it was idealized. But one Greek rebel will break the circle, arguing the sun belongs in the center, centuries before Copernicus. 5. Aristarchus of Samos, the heliocentric heretic, 3rd century BCE. Aristarchus proposed the sun, not the earth, sits at the center, and the earth spins and orbits. He tried to measure the sun-earth distance using lunar phases, brilliant though imprecise. His heliocentric model went largely ignored because stellar parallax wasn't yet observable, and philosophy preferred earth centrality. If Aristarchus was so right, why did Ptolemy, coming later, lock astronomy into a geocentric cage for 1400 years? You're about to see the most influential wrong model in history. 6. Eratosthenes, weighing the earth with shadows, 3rd century BCE. With just 2 sticks, shadows in Syene and Alexandria, and some geometry, Eratosthenes estimated Earth's circumference with stunning accuracy. This wasn't just a party trick. It proved the Earth was measurable, finite, and knowable with math, bolstering the cosmic confidence of Greek science. But knowing the earth is big and round didn't tell them how stars shift. Enter Hipparchus, the data nerd of ancient Greece, who spots the sky drifting over centuries. 7. Hipparchus, precession, star catalogues and precision, 2nd century, BCE. Hipparchus compared ancient star positions to his own and discovered precession, the slow wobble of Earth's axis. He built one of the first comprehensive star catalogues, introduced trigonometric methods, and quantified celestial motion with unprecedented rigour. If Babylonians gave cycles, Hipparchus gave structure. So how did we go from precision observer to a system so complicated it needed dozens of circles to explain a single planet? Meet Ptolemy. 8. Ptolemy, the geocentric emperor of the sky, 2nd century, CE. In the Almagest, Ptolemy wrapped the universe around Earth using deferents and epicycles, circles on circles, to match observed planetary retrograde motion. It worked, mathematically, which is why it stuck. For over a millennium, this geocentric model was astronomy's operating system, not because it was true, but because it predicted. But in a Baghdad observatory, and later in Moraga, astronomers will fix Ptolemy's math and invent clever geometric hacks, one of which Copernicus will quietly borrow. 9. Chinese astronomers, catalogues, comets and supernovae, Zhou Ming, Chinese imperial astronomers, like Zhang Heng, 2nd century CE, built detailed star maps, recorded comets, novae, eclipses, and even invented devices like the seismoscope. Chinese astronomy was continuous and state-backed, producing multi-millennial records invaluable to modern astrophysics, e.g. SN 1054, the Crab Nebula supernova. But across the subcontinent, Indian astronomers were calculating signs, planetary periods, and even arguing the Earth rotates on its axis. Yes, rotates, centuries before Europe accepted it. 10. Indian astronomers, Aryabhata, Varahamihira, and the Sign Revolution, 5th-6th century, CE. Aryabhata proposed that the Earth rotates, explained solar and lunar eclipses without mythology, and used trigonometric signs instead of chords. A mathematical leap. Varahamihira synthesized Greek and Indian astronomy, showing how knowledge flowed between cultures. Indian astronomers produced accurate planetary tables and advanced math, crucial fuel for later Islamic and European astronomy. And then comes the Islamic Golden Age, where observatories, zujiyas, astronomical tables, and ingenious geometric hacks set the stage for a revolution. One model in particular, the Tusi couple, is coming up. 11. Maya astronomers, Venus, ritual, and precision circa 250 to 900 CE. Maya priest astronomers created highly accurate Venus tables in the Dresden Codex, tracked eclipses, and aligned temples with celestial events. For them, astronomy was mathematics, plus mythology, plus statecraft. But their numbers were razor sharp. Their synodic period of Venus, shockingly close to modern values. Yet none of that reaches Europe directly. The bridge, the transmission belt of ancient astronomy, runs through Baghdad, Damascus, Samarkand, and Moraga. 12. Islamic Golden Age, Al-Batan, Al-Tusi, Ibn al-Shatir, 9th to 14th century CE. In places like Baghdad, Toledo, and Moraga, scholars translated, corrected, and surpassed Ptolemy. Al-Batan refined planetary parameters and trigonometry. Nasir al-Din al-Tusi devised the Tusi couple, a linear motion generated by two circular motions, letting astronomers fix Ptolemy without abandoning circles. Ibn al-Shatir built a non-Ptolemaic, yet still geocentric system, whose math resembles Copernicus's, minus the heliocentrism. They created observatories, compiled zajajis, and treated astronomy as a precision science, not a philosophical puzzle. Their tables travelled to Renaissance Europe, priming the Copernican leap. So when Copernicus finally says sun in the centre, he's standing on centuries of geometry, tables, and clever fixes from many civilizations. But what about the cultures that didn't write thick books and still navigated oceans by stars? 13. Polynesian navigators. Wayfinding without instruments, ancient to early modern. Across the Pacific, Polynesian wayfinders mastered stellar navigation, reading star paths, ocean swells, bird flight patterns, and even bioluminescence, without sextants or compasses. While not astronomers in the Greek sense, they were empirical sky scientists, embedding astronomy in memory and tradition, sailing thousands of miles guided by the night sky. So what ties all these astronomers together? Different languages, same sky. But the way they modelled, measured and imagined it tells us how civilizations think and how knowledge evolves. From Babylonian tablets to Greek geometry, from Indian trigonometry to Islamic geometric hacks, from Maya Venus cycles to Polynesian star paths, ancient astronomers weren't just stargazers. They were pattern hunters, model builders, calendar makers, and navigation masters. Some were wrong, gloriously so, but precisely wrong, and that precision is what let later thinkers be right. Key takeaway: astronomy didn't advance because one genius had a revelation. It advanced because each culture left a mathematical footprint on the same sky. If you loved seeing how ideas travel across continents and centuries, let me know which ancient astronomer you want a full deep dive on next: Aristarchus, Aryabhata, or Ibn al-Shatir. And if you want the Copernican revolution decoded using everything you just learned, hit subscribe, it's coming.